Hi guys, welcome to my YouTube channel. Today we are going to solve the daily Leetcode challenge and today's problem name is partition list. So in this question, a head of a linked list is given to us and our value x is also given. And we have to partition it such that all the nodes less than x comes before nodes greater than or equals to s. And we also have to preserve the original relative order of the nodes in each of the two partitions. It means that let's consider the example number one. So in this case, this is the linked list which is given to me and the value of x is 3. So we want that all the nodes having the value less than 3 should appear first and all the nodes having the value greater than or equals to 3 should be in the last in my answer linked list. And the order of the nodes in which they are appearing should be preserved. It means that for my second partition, we can say, which is holding all the values which is greater than or equals to x, in that the order of nodes should be 4, 3, and 5 only, because this is the order in which they are appearing in my original linked list. Same goes with the first partition also, the left partition. All the values which are less than x should appear in the same order. So first 1 should appear, then 2, and then again 2 should appear. And in the end, we'll be merging them, right? So that's how we are getting the answer linked list that we want to output for this particular question. So now let's see how can we solve this question. So like as we discussed while explaining the this particular example itself, we will be maintaining a two linked list. One will be holding all the nodes which are less than x, other will be holding all the other nodes which are greater than or equals to x. And in the end, we will be merging them. So let's see how can we do this. Let's try to understand our approach using this example. So first of all, I have initialized the two linked list. One will be holding all the nodes which are less than x. Other will be holding all the nodes which are greater than or equals to x. So first of all, our head pointer would be at the starting node of my given linked list or the original linked list. So the value of this node is less than x. So what I will do, I will append this particular node into my into the linked list which is holding the nodes which are less than x. So one should come here, and the value of x is 3 in this example. Then my head will be shifted to the next node, that is 4. So 4 is my greater than x or equals to x. So we'll append the 4 into my another linked list. And then what would happen? Then the 4 will be shifted to the next node, that is 3. 3 is again less than or greater than less than or equals to x. So 3 should also come into my second linked list. Similarly, 2 is less than x, so it should come into my first linked list. Then we have the 5. 5 is greater than or equals to x, so it should come into my second linked list. And then we'll be having the 2 in my first linked list. So once we have generated my both the partitions linked list, now it's time to merge them. How can we merge? So the pointer which will be present at the end of my left linked list, I will point it to the I will make the next of this, I will store the address of my head node of my second partition in the next of my this particular node. It means that now this link, the next of this particular node will pointing to this particular node. And now if we will return this node as an answer, so this will be my final or the output linked list that I have to return as an answer. So how can we solve this particular, how can we implement this particular approach? Let's look into the code now. So yeah, this is the implementation of the approach that we have discussed. So first of all, I have declared the two partitions linked list separately. One is the left one and another is the right one. One will be holding all the nodes which are less than x, other will be holding all the nodes which are greater than or equals to x. So first of all, why I have not initialized it with the null but with the value, some dummy value that is -1. So by using this particular approach, by initializing it with -1, it will actually make our code simple and the small. Otherwise, what would happen if you initialize it with the null? So we have to handle the case separately when my left head would be null. So first of all, we have to set the left head and then only we'll be moving to the left pointer. So we can do that also, but it will unnecessarily increase the some number of lines of our code. So and the some if else condition. So we can actually avoid them by initializing our both the lists by some dummy value. So here I used -1 as a dummy value. After that, I have also declared a one pointer. So first of all, these particular head will also helps us to determine where my head of the both the partitions are pointing. And after that, my left pointer and the right pointer will be pointing to the last node of my respective linked list. That is left one and the right one. So after that, what I'm doing, I'm iterating over the original linked list that is given into my answer, whose head is nothing but the head variable. So after that, what we are doing, if my head value is less than x, it means that we have to insert this particular head node into my left linked list. So that's what I'm doing here. So initially, my left node will be here, right? At the initially it would be at the starting node, that is the dummy node having the value -1. So we'll be setting its next equals to the head, the node that is we wanted to insert, we wanted to append. After that, I will be shifting my left pointer to this node. So first of all, what we are doing, we'll be making the next equals to 1, and then we'll be making a left pointer equals to the 1 only, right? So that it will be present at the tail node of my linked list. And after that, what I'm doing, I will be shifting my head to the next node so that now this node, this particular node have been already appended into the respective linked list. Now we wanted to append the next nodes. So we'll be moving head to the next node, and in the end I'm making my left pointer equals to null. And why we are doing it, I'll be explaining after a while. The same thing we are doing for the right linked list as well. If my value of height is greater than or equals to x, it means we have to insert into my right linked list. So first of all, we'll be making right pointers next equals to head, then we'll be shifting to the next node through this, and then we'll be moving on to the next node in my original linked list by making head equals to head next, so that because the current head node have been already appended into the respective linked list, now we have to take care of the next nodes. So that's why we are doing so. And in the end, we are making our right pointers next equals to null. And so after doing this, once all the nodes have been appended into the respective linked list, it's time to merge both the linked lists. So how we merge, as we discussed earlier, the tail pointer of my left linked list. Next, I will make the head of my basically this is the head of my right linked list. So this is the heads next. Okay. So what we are doing, the left pointers next should become equals to right pointer, right head next. Right. So that's what I'm doing here. My left pointer next should becomes right head next. And in the end, I have to return this is the head of my the output or the partitions linked list. So we should return the left pointers next as the answer. So that's what we are doing here. Now, why we are using this particular line? Why we are writing the left pointer's next equals to null and the right pointer's next equals to null? So this is why, because when my two is here, just consider this five. Just consider this five. So what is actually happening? So once you have appended the five as a node into my second partition or into my second linked list, so after that, what would happen? It is not the individual node is not coming and is being appended, but the whole linked list which is there after this should be appended. So it should be like this five, and then we will be having two. But we just want this node only. We don't want the rest of the nodes which are there after the five. So what we can do? We can set its next equals to null, right? Otherwise, what would happen? My answer should be 4, 3, 5, and the nodes which are right there after the 5 would also be there. So 2 should also come. So in order to avoid this thing, in order to just get a single node, not the complete nodes which are there right after that particular node, we should make our nodes, the tail of the both the partitions node to the null, right? So that what I'm doing, the next of my tail should be pointing to the null, so that it should not get all the nodes which are there right after that particular node. So that's why we are writing the null here. So I hope guys you like this particular video. If you find this particular tutorial helpful, then please consider subscribing to my YouTube channel and hit the like button. And if you have any query, please feel free to write it down in the comment section. Thank you for watching.